Okay, class, we are up to weekly update 10. So you guys just finished first half of chapter 1 of book 3.5, so module 5. So I put some activities and samples that I liked in your samples and examples section of that module in OAK. So check those out. I'll mention a few. And then we can talk about the discussion board. That one was really fascinating this week. Your comments on Conrad Wolfram's ideas about computer-based math. So there's a collection of you, like Caroline, Filippo, Colin, Charles, Haley, that talked about, they don't think that should be the future of education. And then there's another bunch of you that talked about, yes, it definitely should be the future of education. And then when you really get down and read them, it's almost, I think most folks are in agreement when you actually do read the details of them. And I urge you guys to go back and read them. They were pretty fascinating. So Colin talked about sort of like other technology classes that he'd had where it's almost a hindrance to learning because the technology and the semantics and all that can really be a hassle. And we're getting better with that. I think that's why we're getting a little closer maybe towards Conrad Wolfram's wish. I really liked a comment from Jenna about the immersion of, you can use computer-based math to get students more immersed in math, and that immersion experience is the best way to learn it. She sort of makes an analogy with language and immersive way of teaching language. And we miss out on that with math when it becomes memorizing. And a lot of folks talked about the memorizing repetition. I think Rian and Haley, Kyra and Ellie, I think were the folks that I remember really saying, like, you almost felt like in your classes you were a robot just being trained to do these sort of mechanical, repetitive things. And how, and then I think a few of those folks, Haley and Rian and or Brianna maybe was the other one, talking about how in that sense, they're almost like dumbed down calculations that you're doing anyway. The type of problems that you can do by hand tend to be not very interesting. And the real life ones, you do at some point eventually have to go to the computer to do some sort of numerical method to solve it. And we've already seen that with some of our stuff in Calc 3 with, for instance, just solving those CP equations to get the critical points. And then another comment was, I think maybe Zach was talking about Conrad Wolfram's comment about it would be nice to teach math by teaching students how to actually program a computer to do those things, those algorithms that you're doing by hand. And I've had students in my graduate class have to do that for this famous algorithm called the simplex. And to do that programming, you have to do a bunch by hand to make the program start working and checking on the examples that you've done. And then by programming the computer to program that, like, you're seeing that many of you talked about the idea of, like, by hand has this sense of like, well, I'm writing, I'm seeing, I'm like verbalizing it, I'm touching, that sort of multiple modes of getting the information into your head. So by doing something by hand, you are getting into the brain, but you can also be doing that in a way that programmed it. So I like Zach's comments on that. And I think he also might have talked about, multiplication sort of being mechanical, like when you teach at a younger. So then there was this debate in many of the posts about at what level should we do this, if we agree with it or don't, at what level do you allow this to happen, or do you start doing it? And I think most folks think about when you learned your multiplication tables, it was mechanical, it was memorizing, but you didn't even really understand what was happening. And there's other ways of teaching that where there's a famous educator, Jo Boaler, talks about how she learned with what was back then, like the new math. And to think about multiplication was not 2 times 3 equals 6. It was 2 is a length times 3 is a length. So we're actually getting areas, and you had this sense of number, and you could then remember, you could almost derive. Okay, so the 12 times tables were a little bit harder, the 11 were harder, those were mechanical. But if you, instead of memorizing, thought about those, or actually 12 is like 2 times 6, and then I'm going to multiply that by, say, 11. And so I can split it up and do these little tricks in learning how to do these. And she talks about how that did not impede in any way. I mean, she's a PhD mathematician in her future. So it's the idea of concepts. And many of you hit on that. Like it can, if you can use computer-based math to enhance your understanding of the concepts and not replace it, then maybe we're taking steps forward there. And one that maybe summarized all that was Grace's comment about, well, you just need this balance between the two. They really should handshake along the way and work together. And it shouldn't be that you're, in many of your experiences, just can't use that computer. You can never use the TI. You can't. And there should be some sense where you have to do a bit of both. Let's see, many of you mentioned this sort of aspect of math as like the puzzle nature that you enjoy. And Sam maybe had a comment too about there is a sense of reward after you do spend 20 minutes on a hand calculation of a problem, and you get this nice clean answer. Oh, it's 2, the critical points are 2 and 4. And then he kind of says, well, maybe that's sort of a false satisfying feeling, because in the real world, they aren't gonna be that nice and clean. And you have to have this frustration and sort of lack of confidence when you got the answer of 1.17 and, is that right? And then you have to have a better way of checking. You almost use that cleanness to check, okay, I must have done it right, I'm good. So that was an interesting take on it. And then finally, another one to really read is Christian's. I thought it was a great summary of, and this is my whole point, I guess, what I'm trying to teach is I want you guys to go off and discover and create and invent new things. And I think you do need both. You need the concepts and the calculation to do that. And with just one or the other, you probably can't. And you have to get you to that level, you have to understand the concept so thoroughly that you could take that concept and generalize and extend it and tweak it just a little bit and come up with a totally new thing. But probably then to test that in real applications and real world problems, we're going to need the computer and the calculation abilities. Okay, so enough on that. I do urge you guys to check it out. Let's see, the calculations this week, nice job. There were some excellent ones. I think I put Rian's and Kyra's and maybe Jenna's in the samples and examples. But Rihanna's just got beautiful handwriting, excellent explanation. So if you're just going, check hers out. In general, it's a nice one to follow. So there are a few folks that also said or have emailed me or had comments when they submitted their Dropbox that they're having a little trouble with parts of it, like the line part, where the calculation one. So check out these students, but also many of you did in the Module 4 discussion board that you wanted to have some study buddies. So please contact those folks. So if you had a little trouble on parts of beginning of Chapter 1, contact the folks that were in that Module 4 study board that are looking for study buddies and get up with them. I have my 105 Express 2 class started, so I'm just like swamped with 90 students, 100 level students just emailing me constantly. So I'll do as best I can, and I might add you guys to jump onto their office hours whenever you have questions, but use each other as a resource. That's also going to help you get ready for the final. Okay, the next thing, the activities, I put a bunch of really good ones in there too. Jenna, as usual, made a movie that was interesting, added a lot of interesting extra details. And then I think our usual crew, like Lily and Emma and Ellie, had some nice ones. I think I put Kyra's, Joe's in there, excellent examples as well. And let's see, am I missing anybody on those? And there again, Module 5's week 1 in the samples and examples section. Okay, and then so Jenna's movie brought up a few points that I want to quickly close with. So most of you did the personality match as an activity, and you talked about if you were making a matchmaking service or like a dating service, would you want those things to be pointing in opposite directions? We have 2 vectors in opposite directions. Do you want them pointing in similar directions or orthogonal? A lot of people settled on orthogonal because they thought you don't want someone just like yourself. You don't want someone that's, some people say maybe opposites attract isn't necessarily true, but orthogonal might be enough difference. So that was the one folks settled on, but Jenna's take was an extension of that to do like a weighted matching where she would let you have a weight for every one of those 5 features. So you could say like, I'm really interested in how organized this person is, or I'm not at all interested. So that weight is like close to 0, but another factor I'm much more interested in. And so you could add weights to those, and then you could do that same dot product with like a weighted dot product, right? So getting your angles in a weighted sense. So you'd have almost slider bars for people to pick what they wanted, and then the same idea would get you there. Okay, another one, several of you did the search engine one and talked about that. What would it mean? Negation. So yes, if we're just doing frequencies and counts, all those vectors are pointing out of the non-negative orthant, is what we call an RN. So all those vectors, especially, so Jenna's point was, okay, I get that. We have a bunch of vectors shooting out into the non-negative. But what about the query vector? So the query vector, you might want to say, which some advanced searches say, she said, for example, I want to search on dogs, but I don't want anything to do with cats. And so you can somehow, in the search engines, they allow you to do that. So to do the negation, that's actually a very difficult open problem. So she was like, maybe I could put a negative number in there. And so I have all these vectors shooting out of the non-negative orthant, but then I have a query vector that is not in that, not necessarily in that non-negative octant. And I just want to point out, because a couple of you also mentioned this, just how difficult the idea of negation is for search engines. And so this is, again, something that I just love as part of my research. I saw one page similar to this when I was in graduate school and just took off reading a bunch of books. So if you're also interested, shoot me an email. If you're someone, I have plenty of articles and things at different levels, but the main thing would be take linear algebra. That's the next best class to learn some of the tools that are underlying in search engines. And then the next comment from Jenna I thought was super cool was something about the synonyms, that how do synonyms work in this sense? And this is super cool. Again, if you had linear algebra 203, you might have learned about a decomposition called the singular value decomposition. If you haven't taken that class, you'll love it, depending on who teaches it. And I think Kate Owens is set to teach it next semester, so take it with her. And so this is a way where we have a bunch of these vectors, we put them all together, that makes a matrix, and then we do some sort of decomposition of this matrix. There's many ways to do that, you'll learn several, but this one, the singular value decomposition, says, okay, this matrix has a lot of vectors in it and a certain rank, some measure that they take, and what if I just looked at a lesser rank version of this matrix? It's almost an approximation of this matrix. And when you do that, you're actually you're reducing the, you're really sort of collapsing some of those terms into clusters of terms. And so those clusters of terms end up holding synonyms. So like for vehicle, car, automobile, they would all end up in their own cluster of terms when we do this decomposition. And so that's how we can actually get at synonyms. So again, the math that does this is amazing. It's, again, one of the coolest things for me that I learned. It's like, I love the usefulness of that, and I want to learn more about it. And so I did that as my postdoc. I think I mentioned that in the intro video, and I've been studying it since in different methods. But one of the things I did, I learned that my PhD research was on something called Markov chains, and that's what was underlying Google's PageRank algorithm. So they took this sort of dot product idea, but they extended it. They took that decomposition idea, they sort of extended it in a different way, and they could rank documents based on where, how likely they were if you're a random surfer bouncing on the web to land on a page like that. And in writing that book, I got to be asked to be a scientific expert on a court case that ended up running for like 7 years. And in that court case, I got to look under the hood of all the most famous search engines. So I got to see Google, Yahoo, MSN. They also then did Facebook and social media ones because they all rely on the same sort of technology. In doing that, though, again, I got to see how these search engines work and what are issues to this day, and how they, what are the workarounds and how we resolve that. So synonyms and negations are still, again, there's methods, but we're not maybe super satisfied. So they're not perfect, and they're open questions for us. So I thought it was super cool that some of you are excited about that too, because that's one of the things that set me off down the path that I've been working on. Okay, well, that's it for the comments on this week. You guys did a nice job. I think you'll have even more fun with the second half of this. And then chapter 2 has so much cool stuff in chapter 2. So build your foundation now so we can get ready for chapter 2. We're doing all sort of basic linear things, and then we get to chapter 2 and we'll be non-linear. Okay, have fun. Have a good week.